Hi, this is Dr. S and this is video 4 in reaction rates for Year 12 chemistry. This is about measuring rates. So setting up an investigation that would produce reliable data for us to determine the rate of a reaction as a reaction proceeds. Now at Year 12, the sorts of reactions you will have to do this with are reactions that produce gases. So common reactions that you will have seen that produce gases would be something like magnesium plus an acid, in this case HCl, to produce magnesium chloride and hydrogen is a gas, so that is the thing we'll be measuring. You might have also seen something like calcium carbonate plus HCl to produce calcium chloride, carbon dioxide and water, and again here it would be the CO2 that would be the gas that we'll be measuring. So there are two ways in which we can measure the amount of gas produced. The first way is by actually measuring how much gas is produced every, say, 10 seconds so we can put it on a graph. So I'm going to show you an experimental setup that would allow us to do that. And you might have seen this before. Forgive the crudity of the drawing, I'm not an artist. Here we have a conical flask with a reaction mixture. It's sealed at the top to allow all of the gas that's produced to be diverted through this tube into a measuring cylinder that is upturned and filled with water. As the gas is produced, the gas displaces the water, and then we can measure how much gas has been produced every 10 seconds, 20 seconds, and put that on a graph. A slightly less messy way of doing it, if you have the equipment, is by using what we call a gas syringe. So similar setup, reaction mixture in a sealed conical flask with a delivery arm here. The gas is then being diverted through the delivery tube into the gas syringe. As the gas enters the gas syringe, it pushes the plunger out, and there are markings on the gas syringe that allow us to then measure how much gas has been produced every, again, 10 seconds, 20 seconds, so we can graph it. Ultimately, what that will lead us to is a graph that looks something like this, where we have volume of gas produced over time. I will come back to this graph in my next video. Now there is another way we can measure the progress of a reaction that produces a gas, and that's by measuring the mass of the gas that escapes. So if you imagine a situation where we have a conical flask which has a reaction mixture in it that is producing a gas, that gas is escaping. And the gas has a mass, it's not very heavy, but it does have a mass with it. So if we carry out this reaction on a top pan balance, then we'll have a reading on here. And as the reaction progresses, that reading will decrease because the mass of the solution is actually decreasing a little bit because the gas is escaping. It won't decrease by much. But if you've got carbon dioxide as the gas that's being produced, it will be heavy enough to cause a noticeable decrease. And again, you can measure that every 10 seconds, 20 seconds and create a graph from that. I wouldn't recommend this technique with hydrogen. Hydrogen is a very light gas. You wouldn't notice much of a difference on your top pan balance. So if you're producing hydrogen, it'd be better to use a gas syringe or the upturned measuring cylinder method. Okay, so either of those allow us to create a graph. Next time we'll look at how to use the graph and how to actually determine and quantify the reaction rate at any particular time from that graph. Okay, I'll see you then.